There's an article that just came out that describes something most people believed was impossible. This is not clickbait, it's not exaggeration. It's the actual headline from Reuters. One of the most credible news organizations in the world. Chinese scientists have built a prototype machine capable of producing the cutting-edge semiconductor chips that power artificial intelligence. Let that sink in. This is the exact technology the United States and its allies have spent years trying to prevent China from accessing. We're talking about extreme ultraviolet lithography, EUV, the most advanced chip-making technology on the planet. This is the technology behind every frontier AI system. The chips that run models like ChatGPT, Claude, and every other leading AI today. For the past 6 years, the United States has led the most aggressive technology blockade in modern history. Export controls, sanctions, diplomatic pressure. The Netherlands was pushed to block ASML, the only company in the world that makes EUV machines, from selling them to China. Each of these machines costs roughly $250 million. They weigh around 180 tons. They're the size of a double-decker bus and take multiple cargo planes to transport. ASML spent more than a decade building its first prototype and another decade turning it into a commercial system. 20 years of development, billions in research and engineering. China was locked out of all of it. And yeah, according to Reuters, they now have a working prototype. This machine was completed in early 2025 and is already undergoing testing. This isn't a lab experiment. It's a factory-scale system that fills an entire manufacturing floor. In fact, it's reportedly even larger than ASML's machines. Instead of miniaturizing the design, China appears to have brute forced it by scaling everything up. And here's the part that should concern everyone. The machine was built by a team of former ASML engineers. These weren't junior employees. These were people who spent years, sometimes decades, building the most advanced lithography systems in the world. People who understood the design decisions, the failure points, the troubleshooting, the institutional knowledge you can't learn from papers or patents. China began recruiting this talent aggressively in 2019, offering signing bonuses in the hundreds of thousands of dollars. In some cases, far more. One former ASML executive responsible for EUV light source technology moved to China. Within 18 months, his team filed 8 EUV-related patents. According to Reuters sources, reverse engineering these machines would have been nearly impossible without that human expertise. Dutch intelligence had warned about this for years. Systematic recruitment of Western engineers in strategic technologies. Those warnings were not taken seriously enough. Despite export controls designed to block access to key components, China still acquired enough parts through secondary markets, decommissioned equipment, and salvaged systems to build a functioning prototype. Now, before the panic sets in, it's important to be precise about what this machine can and cannot do. It has not yet produced working chips, but it is operational. It is successfully generating extreme ultraviolet light at the required 13.5 nanometer wavelength. That alone is an enormous breakthrough. The EUV light source is one of the hardest components to build. ASML's own leadership had publicly stated just months ago that China was many years away from achieving this capability. That timeline has already been shattered. Still, producing light is only part of the system. Turning that light into nanometer-scale patterns on silicon wafers at industrial yields is an entirely different level of complexity. Think of it like this. They've built an engine that runs, but they haven't driven the car yet. There's still the optical system, the wafer stage, the photoresists, the masks, the vacuum environment, the precision motion systems. ASML spent a decade going from functional light to commercial chip production. China now claims it wants working chips by 2028. Engineers closer to the project suggest 2030 is more realistic. Even that is shocking. Analysts previously believed China would not reach this level until 2035 or later. This isn't a shift of months, it's a shift of years. Every strategic assumption built into US export policy assumed China was at least a decade behind, that the West had time to secure supply chains, maintain dominance, and control the pace of AI development. That time has evaporated, and this isn't the first time timelines have been wrong. People said China couldn't compete in AI. Then DeepSeek arrived with frontier-level performance at a fraction of the compute cost. People said China couldn't make 7-nanometer chips without EUV. SMIC did it anyway using older equipment and complex workarounds. Each time China is constrained, it doesn't retreat. It concentrates resources, recruits talent, and accelerates. This EUV prototype appears to be part of what Chinese media has described as a Manhattan-scale national effort. It's overseen at the highest levels of government, not buried in a ministry, not delegated to corporate labs. This is a national strategic priority. Unlimited funding, centralized coordination, political urgency. That matters. Because the original Manhattan Project succeeded not because it was efficient, but because it had everything. Talent, money, secrecy, and authority. China has all of those. And the goal isn't just chips. It's technological sovereignty. Removing US leverage across semiconductors, AI, operating systems, satellites, and infrastructure. If China achieves full semiconductor independence, it can build frontier AI systems without relying on Western hardware, licenses, or controls. That changes everything. The foundational assumption behind Western AI policy is compute dominance. That no matter how smart Chinese researchers are, they'll be limited by access to advanced chips. That assumption is now fragile. If China can manufacture state-of-the-art chips domestically by around 2030, the compute bottleneck disappears. DeepSeek already showed what happens when algorithms are optimized under constraint. Imagine what happens when that constraint is gone. Most estimates place AGI somewhere between the late 2020s and early 2030s. That puts the arrival of general intelligence dangerously close to the moment China may achieve full semiconductor independence. And that raises a deeply uncomfortable question. What happens if China reaches AGI first, or reaches it at the same time, without the safety culture, alignment research, or public accountability present in Western labs? Western AI development is imperfect, but there is at least open debate about risk, alignment, and control. In China, development is opaque, state-driven, and optimized for strategic advantage. In a race where both sides know the other is close, the incentive is to move faster, not safer. That's the dynamic everyone warned about. And now the timeline is compressed. Hardware controls were supposed to buy time. That leverage is weakening. This isn't just a semiconductor story. It's an AI story. It's an AGI story. It's about who builds the most powerful technology in human history, under what constraints, with what values, and whether anyone retains the ability to slow things down if the risk becomes unacceptable. Right now, that question no longer has a comforting answer.